What is this? This is a pool that I wouldn't want to swim in because it's mathematically stupid. But let's go ahead and go through this question and let's try to make sense of it. I think, personally, if you know what to do, I think it's the biggest piece of cake on the face of the planet. But if at first glance, you're like, oh God, like you want to like throw up, like it's bad. Let's take a look and see what the question is asking us to do. A rectangular in-ground pool is modeled by the prism below. The inside of the pool is 16 feet wide and 35 feet long. The pool has a shallow end and a deep end, with a sloped floor connecting the two ends. Without water, the shallow end is 9 feet long and 4.5 feet deep, and the deep end of the pool is 12.5 feet long. Okay. If the sloped floor has an angle of depression of 16.5 degrees, what is the depth of the pool at the deep end to the nearest foot? Oh, sorry, tenth of a foot. So I want to talk about this right here. It's saying, what is the depth of the pool at the deep end? In other words, it's asking you to find the depth of, it's really English there. How far down is the deep end? That's basically what it's asking you. It's asking you to find this, or it's pretty much the same thing because, you know, it's a rectangular box. So, unfortunately, there's no specific way to solve for this using any, like, you know, volume formulas or anything like that. You actually need to use dissection. What do I mean by dissection? Dissection means that you have to break down this figure into baby pieces. Let me explain why. Let's say, all right, so I'm going to actually to extend this dotted line here. I'm going to extend it over here. I'm going to extend it over here as well. Watch what I'm doing here. And this is quite, in my opinion, it's pretty cool. Listen, I really do think it's a cool question. I do. But on a Regents, I'm sorry, you shouldn't be putting this on a Regents exam. So, by dissection, you need to dissect this pool by the following. You need to make this a gigantic rectangular prism. You see the top layer here? It's kind of like a cake. You see the top layer? I'm making this pink. This is a rectangular prism. We know how to work with boxes. This is a big box. Are you kidding me? Thank you. This is a big box. This down here is a smaller box. We know how to work with small boxes. Pretty simple so far, right? Not too bad. Okay. Now, the problem is, what is over here? This is a triangular prism. This is a triangular prism. Okay? You see what I'm trying to do here? I'm cutting this into a big rectangular block at the top, and I'm slicing this at the bottom into a triangular prism and a rectangular prism. So here's what we got to do. Find the depth of this. Okay. So the first thing that I need to do is I have 4.5 feet. I know that a portion of this is 4.5. I'm missing this, the bottom of it. Well, the bottom of that is right here as well. That matches this, which matches this. Well, the problem is we don't have that at all. All we got is a freaking triangle here. Well, what do? This is what we do. We are going to be using trigonometry to solve for that side. I think I have a copy of it. Okay, hold on one second. I'm going to take a copy of this and I'm going to overlap it real quick, just to zoom in what I'm talking about here. Your goal is to solve for this right here. The problem is we only have an angle. We don't even have a freaking side. How are we dealing with this? You need to be smart about it. They tell you that this is 9 feet. They tell you that this is 12.5 feet. They tell you that the whole length is 35 feet up here. You see how mean this question is? You need to get this length, the blue line right there, by taking 35, subtracting 9, and subtracting 12.5 feet. Okay? So this line right over here has a length of 13.5 feet. Now we could use trigonometry SOHCAHTOA. Let's do it. So, this, we're trying to find this. I'm going to call that x. We're using SOHCAHTOA. This is the opposite. This is the adjacent. This is a right angle over here. This over here. This is the hypotenuse. We're not working with the hypotenuse. Sine and cosine are out. You are using tangent. So, let's solve for x. The tangent of 16.5 degrees is equal to the opposite side, which is x, over the adjacent side, which is 13.5. We are going to cross multiply this. 13.5 tangent of 16.5 equals x. Go to your TI Nspire graphing calculator. Type it in. 16.5 tangent. Oh, I'm sorry. 13.5 tangent of 16.5. Come on. 3.99888. Okay, so x is equal to 3.99888. Now it's saying find the depth of the pool. So we're just taking this, the 3.99888, and we're adding it to 4.5 to get the whole deep end. So we are just going to add 4.5. The deep end is equal to, when you add those up and round it to the nearest tenth, you get an answer of 8.5. So the deep end of this pool is 8.5.